Okay, so now we're talking about the lovely little city of Buffalo. So I got a cheesy little reading, and basically the idea of Buffalo shows you, those poor Buffalo Bills, gotta love them. It shows you the idea of lake effect snow. So in the bottom right corner here, it says that we want to label a few things on the map. So you know where all this stuff is already. So we'll go to the back here really quick, and we'll try our best to label some of this stuff. Okay, so you should know this lovely lake right here. It's our favorite at this point. So there's Lake Ontario. Okay, and this lovely little guy. And so if we keep going here, we've got Lake Huron there. Okay, this will be Georgian Bay. Okay, we can even do this one. Sorry if you can't read the writing. It's Lake Simcoe. Okay, and then this little one here even, bottom left corner, you got, so it's Lake St. Clair. And, well, we got a few North Bays in there as well. We got a bunch of stuff. Okay, so now we're looking to label a few cities here, so you should know where we are. Somewhere in that general area right there, and we'll call that Toronto. Okay, and then somewhere right around there, towards the end of the lake, you got the lovely city of Buffalo. Okay, so we're talking about a concept of lake effect snow here, and so my overall question here at the bottom, so why does it snow more in Buffalo than it does in Toronto? If you go to the bottom corner of your page here, so it says label Lake Ontario, Lake Erie, Lake Huron, Lake Simcoe, Georgian Bay, as well as Buffalo, Toronto, London, Kingston. So we missed a couple cities. So London and Kingston, my standard way to memorize them, it's somewhat in between Sarnia and Hamilton, and then slightly above that line. So I could be a little off with my plotting here, but if I go Sarnia to Hamilton, and I'm about halfway, and I go up a little bit, I should be pretty close. Okay, so we'll call London somewhere in that general region right there. Again, I could be slightly off, but that's okay. We'll get the idea. So that'll be London. And then Kingston, again, we're out in this general region right here, which is a fairly big region. We're gonna plot Kingston somewhere around right there. As I look at that, it doesn't look 100% accurate, but you'll get the idea. Okay, the last thing it asks you to plot on the bottom here is draw arrows to simulate the dominant wind pattern. So the dominant wind pattern, you should remember, our typical dominant wind pattern in this region, based on global circulation model and all the rest, our dominant wind pattern comes from the southwest. Okay, so the dominant wind pattern comes from the southwest. So again, these might not be the most accurate southwesterly winds in the world, but we're gonna take them. And they should, you know, be relatively decently parallel lines. I don't think you need a massive stretch of the imagination to visualize what's going on here when we get to it, but we're going for relatively parallel lines. And as you look at this, it looks half decent, what the heck. Okay, so so basically my question then is, why does it snow more in Buffalo than it does in Toronto? And so in lake effect snow, when Buffalo gets a lake effect snowstorm, you can find YouTube videos and stuff like crazy, and they literally get hit with a blanket of snow. I saw one video quoting it as it was literally puking snow. I think that might be the first or second link on YouTube. It's actually kind of funny. I don't know why they use puking on the news. But anyway, so why does it snow more in Buffalo than it does in Toronto? Simply a product of the location, and the location relative to the lakes and relative to the dominant wind pattern that typically happens. Toronto experiences a lot of lake effect snow, especially close to the waters, but it's typically when the winds are coming from a different direction. But so Buffalo receives it more dominantly than we do, or more often than we do. And so water is a really cool thing. So water has a greater ability to hold heat. Water holds heat better than land. Okay, and so when water holds heat better than land, it heats up and cools down more slowly. So you probably experienced this yourself if you're at a cottage or something like that. I guess I could say more slowly than the land. So if you're at a cottage or something like that, and it's the Victoria Day long weekend, let's say, and it's very hot outside, and you go to jump into the water, Well, good luck, because the water is going to be very cold. Just the same in August, late August, August. In the evening, when the temperature starts to go down, it gets that little bit cooler, and you want to almost get into sweater weather. The water will actually feel fairly warm relative to the temperature outside, right, and relative to the land and all the rest. So water holds on to heat better than land, and water then, also heats up and cools down more slowly. So it takes longer to get colder and takes longer to get warmer it takes longer to balance itself out with the swings in temperature, with the changing of the seasons and all the rest. So our dominant winds then, winds pass over water, and when they do that, they obviously pick up moisture, and they'll also warm up in temperature as well, but pick up moisture, then hit land, and I'm going to write CCF, because when they hit land, you should know this, air rises, then it cools, condenses, and falls. So they hit land, and then they cool, condense, and fall. So it just so happens that Buffalo happens to be in that direct path of the wind going across Lake Erie. So this wind is going to pick up moisture the entire time as it passes over Lake Erie, pick up, and then cool once it hits land instantly and literally dump a wall of snow on Buffalo when the winds are blowing that way and the temperature of the water is just right. Typically this happens in the early parts of the winter, the Novembers, the Decembers, when the difference between the temperature in the water, still retaining a lot of its heat, and land is more, there's more of a difference, or a noticeable difference between the two temperatures. So why doesn't it have this effect when you go in Toronto? Because, okay, if the wind's blowing in the same direction, you'll have a stretch there of land that wind will pass over prior to hitting Toronto. And it's kind of noticeable that London is right along that path of the land, let's say, right? And so what you end up with is something known in Southern Ontario as the snow belt. And you actually notice if you fly to Thunder Bay or something like that, or if you're flying out west and it's in the wintertime, you'll actually fly, let's say you're flying WestJet from Billy Bishop or something, you'll fly up here this way, and the second you hit Barrie, you'll notice that all of a sudden everything's white. Everything goes from being green to white, depending obviously the snow and all the rest. But it's a really cool visual when you notice that. I should have drawn London in the snow belt, but you'll notice that all of these places receive a ton of lake effect snow. So where does this predominantly happen here? Out this way. When the winds are blowing, the same winds that would dump snow on Buffalo would dump wind out in Kingston, right? Would dump snow around, did I say dump wind? Dump snow on the far side of Lake Simcoe, right? The entire Tobermory Peninsula, or the Bruce Peninsula, all the way up here, right? Even North Bay would experience it and all the rest. And so Toronto does experience it typically when the winds are coming from the south. And this happened on the weekend here. I don't know when you're watching this, but it happened. You'll have a southerly wind dumping a ton of snow right around the lake. Not so much experienced once you just get past the city. And so Buffalo then is obviously in this huge Niagara Falls, Buffalo dumping ground of snow based on dominant winds and Lake Erie snowbelt. As I said, I should have drawn London in this way, because London, if you have any friends and family that live out there, if you get 0 days of snow days where school is canceled, they will get a solid 15 or so. Typically just because predominant wind pattern, blowing snow, picking up moisture from the Great Lakes and dumping it, the second it hits land, cools, condenses, and falls.